Keep waiting, everybody. Next. So in today's class, we're going to see the next concept is law of conservation of energy. So what is this law of conservation of energy? And there is an activity to prove that law of conservation of energy. So we'll discuss that in our today's class. So what?
So we discuss some numericals
Yeah,
in potential.
yes, no. So we'll discuss it and then we'll proceed. Okay. So right, I think one numerical you have written. Am I right?
Yes, sir.
So right. An object of mass 12 kg. An object of mass 12 kg is at a certain height above from the ground, is at a certain height above from the ground, is at a certain height above from the ground, is at a certain height above from the ground, above from the ground, above from the ground. If the potential energy of the ground, if the potential energy of the object is, if the potential energy of the object is, potential energy of the object is 1500 joules. 1500 joules. Thousand five hundred joules. Calculate the height of the object which is above from the ground. Which is above from the ground. Understand, everybody? So what is the height they are asking above from the ground? So we all knows that potential energy is equals to mgh. So now h we want it. So h is equals to what is that? Potential energy divided by mass into acceleration due to gravity. So potential energy is equals to 1500 joules. Mass is 12 kilogram into acceleration due to gravity is 10 meter per second square. So why I will write units also here. You all should need to know the units, how the units transformation. So we all knows that 1 joule is equals to how much, everybody? 1 joule is equals to how much? All of you respond. 1 kilogram meter square per second square. Is it right or wrong? All of you? And we all knows what is the unit of height, everyone? Only meters. Is it right, guys? All of you?
Yes, sir.
Yes.
Yes, sir.
So what will happen, everyone? So we'll replace with that now. So 1500 kilogram meter square per second square divided by 12 kilogram into 10 meter per second square. So what will happen? Kilogram will get cancelled. Meter square, second square will get cancelled. Meter and square will get cancelled. So 1 meter is remaining. That's all. So which is equals to 1500 divided by 12 into 10. So this also will get cancelled, which is equals to meters. So 150 divided by 12. Solve it and tell me fastly, everybody. You understand, everybody? What is the answer?
12.5.
Yes. So you can take it 150 divided by 12. So what is the answer will come? 12.5 meters. So object is present 12.5 meters above from the ground. So H is equals to 12.5 meters above from the ground. So where mass is equals to 12 kg. So then the energy possessed by the body is 1500. Clear everybody? Understand? Next question. Right. A woman does 700 joules of work in lifting a 30 kg. A woman does 700 joules of work done. A woman does 700 joules of work done in lifting a 30 kg bucket of water. In lifting a 30 kg bucket of water from well. In lifting a 30 kg bucket of water from well. Calculate the depth up to which the bucket. Calculate the depth up to which the bucket is raised. Up to which the bucket is raised. Up to which the bucket is raised by her in the well. Up to which the bucket is raised by her in the well. Clear everybody?
Sir, can you repeat it again?
A woman does 700 joules of work done. Woman does 700 joules of work done in lifting a 30 kg bucket of water from the well. From the well. So like imagine there is a well, deep well. Okay, so the bucket is, the woman is standing and she has been brought a bucket of 30 kg water. So 30 kg water, and she has been done 700 joules of energy. So what is the depth she has been raised up? That is what is the question. So what depth up to which the bucket is raised by her in the well? So G is equals to 10 meter per second square. This is what is the question. So what is the answer? Everybody? So what is that, everybody? She is lifting the bucket. So it is a what energy? Potential energy or kinetic energy? It is the potential energy, which is equals to amount of work done. So which is equals to how much now? Which is equals to 700 joules. So the potential energy, or you can take work done against to gravity also. What is the formula? mgh. So now h is equals to here depth. That is what they are asking. So h is equals to potential energy or work done divided by mg over. So potential energy is 700, mass is equals to 30 kg, and g is equals to 10. So over. So what is the answer? Anybody? 7 by 3 meters. So 7 by 3 meters means how much? All of you. 2.3 meters. That's what you have to remember. Do it, everyone. Understand, everyone? All of you?
Yes, sir.
Yeah. Make it fast. Next. So like this, potential energy is not is tough. It is actually very simple. You can solve. Still, if you want it, we'll solve some sums and then we'll make it. So, all of you write. See, there's nothing will be there. Only the single formula will do always in the questions. So, yeah, of course, in exercise there will be few questions. That questions will solve that. So now, if you want it, now you can make it, write it. Like we can say that the toughest way of asking questions. So how it will be? You can ask, right? So right, that the weight of a person on a planet A. So it is actually regarding gravity also. So it's not required, I think, now. So we'll discuss it that questions later. So now we'll discuss regarding potential energy. So write the question, all of you. Yeah. There is no question related. Right, all of. If the potential energy of a body is held at, if potential energy of a body is held at, if potential energy of a body held at some height from the ground is 20 joules. If the potential energy of a body held at some height from the ground is 20 joules, 20 joules, 20 joules, all of you understanding? Clear? If the potential energy of a body is held at some height from the ground is 20 joules. So some h height I have kept, the potential energy is equals to 20 joules. Now, question is, calculate the potential energy. Calculate the potential energy. Potential energy. If the body is taken 3 meters away from initial height. Do you all understand what I'm saying? Question. So question understanding is very important. I hope you all understand, everybody. Clear?
Yes, sir.
Yeah. So initially body is at some height. We don't know that. So what will happen? It is having a potential energy of how much? 20 joules. All of you understanding? So now if it has been taken to some other height, which is 3 meters above from the initial height, then what is the new potential energy they are asking?
So we need to keep it as x plus 3.
X plus 3. But first initial height you have to find it, correct, Maru? Do you understand?
Yes, sir. Initial height is x, sir.
Yeah.
It is 3 meter away, sir. So that plus 3.
Yes, Mari, that plus 3 first initial height you have to find it for second one. Do you understand it?
Yes, sir.
Yeah. So what is that, everybody? So we all know first case, let us find. This is the two cases actually. So initial height. So potential energy is equals to 20 joules they have given. So we all know potential energy is equals to m into g into h. So h is equals to potential energy divided by mg. So potential energy is 20 joules. Mass is how much? Not given. Am I right? Yes or no? All of you. So let mass is equals to 2 kg. To consider, because it can be solved without mass also. So how it will be means we will write the term mass is m only. That is what we will take it. So let mass is 2 kg have taken. So g value is 20. So what is the height, everybody? So everything will get cancelled. So how much meters will come? 1 meter. Am I right, guys? Please respond. Yes or no?
Yes, sir.
Yes. So now initial height is how much, everybody? We have been found it. Initial height is 1 meter above. Now then from there it has been taken to how many meters? From there it has been taken to how many meters?
3 meters.
3 meters. Means 1 plus 3, which is equals to total height is how many meters now?
4 meter.
So then what is the new potential energy they are asking? So what is the answer? Which is equals to m into g into h. So mass is 2 kg, g value is 10, and h is 4 meters. So which is equals to,
82.
yes. So 42 into 8, 80 kilogram meter square per second square, which is equals to how many joules? 80 joules. So this is one of the most important way of asking numericals. So they will give you some x height and they will mention the potential energy. And then they will give you, from there it has been taken to somewhere up or down. If it is bringing down, you have to minus it. If it is going up, you have to do the plus. Do you understand, everybody? Clear?
Yes, sir.
Yeah. Completed, everybody?
Yes, sir.
Make it fast. Any doubt, anybody can ask me. So write it, everybody. Next. A body has 150 joules of energy at some height. A body has 150 joules of energy at some height. A body has 150 joules of energy at some height. Whose mass is 2000 grams. Whose mass is 2000 grams. Do you understand here? Indirectly they are asking. Are you clear, everybody? Whose mass is how much? All of you?
2000
2000
gram.
grams. If it will falls freely, and reaches to a height of 5 meters, sorry, let me take it 2 meters below the initial height. 2 meters lower or below, you can take it. So make it fast, everybody. If you solve it, then I'll teach. What is the calculate the new potential energy? Answer? Calculate the potential energy 2 meters below the initial height. So first find the initial height, everyone. What is the initial height, guys? What is the initial height, Ra? This much time,
7.5.
7.5. Okay. So first initial, what is the potential energy in Vedan? Which is equals to how many joules? 150 joules. Mass is equals to 2000 grams they have given. So, but we must in what? Kilograms. So we all know 2000 grams, which is equals to how many kilograms? Everybody. 1/1000 kilogram. So please learn 1 gram is equals to 1/1000 kilogram. So if you have been done that, which is equals to how many kilogram we'll get? Love you. Yes, please. 2. So that is what is mass. Then we can find it. So potential energy is equals to mgh. So what is the h is equals to everybody? Potential energy divided by mg. So initial potential energy is 150 joules. Mass is 2 kilogram, 2 kg, and g value is 10. So 10 will 0 0 will get cancelled. So 15/2, which is equals to how many meters? All of you. 7.5 meters. Am I right? All of you clear?
Yes, sir.
Yes, sir.
Yeah. So now it is come down 2 meters below from the initial height. So initially it is at 7.5 meters. Now it is come down to the 2 meters below. So 2 meters below means now what is the height, everybody, from the ground? All of you? How much it is? All of you?
5.5.
5.5 meters. That's all. Okay, now calculate the new potential energy. So what is that? mgh. So m is 2 kg, g value is 10, height is 5.5 meters. You cannot find it. Everybody? What is the answer? 20 into 5.5, which is equals to?
110 joules.
110.
110.
110 joules. Everybody solve it. Solve fastly, everybody. Clear, everybody? Next. Everybody solve. Kishore, Niroshi.
Yes, sir.
Yeah. So next, right, everyone. So this is what enough about the potential energies. So the next concept which we are going to study is actually the most important one. That is what law of conservation of energy. All of you keep reading. Law of conservation of energy. So like chemistry, you might be studied law of conservation of mass. So same way here we are going to study law of conservation of energy. So what you study about law of conservation of mass? Anybody can tell? Yes, please.
Mass neither be created nor be
Mass neither
destroyed.
be created nor be destroyed, but it can be during any chemical reaction or physical reaction, mass neither be created nor be destroyed, but it can be transformed from one form to another form. So same way here, the energy also, remember, like we studied in physics second chapter, force and laws of motion, we studied conservation of momentum. Do you all remember, everybody? Conservation of momentum. So what conservation of momentum will speak about? Momentum, initial momentum is equals to final momentum. That is what momentum before collision is equals to momentum after collision. Am I right? All of you?
Yes, sir.
Yeah, momentum
Yes.
before collision is equals to momentum after collision. So same way here, law of conservation of energy means Remember, energy can neither be created nor be destroyed, but it can be transformed from one form of energy into another form of energy. So that is what we used to call it as law of conservation of energy. Write it, everybody. According to the law of conservation of energy, 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 energy can neither be created, energy can neither be created, energy can neither be created, energy can neither be created nor be destroyed, nor be destroyed, nor be destroyed, but can be transformed from one form to another. Can be transformed from one form to another. One form to what? Another.
Another.
So that is what we will say is the formula. Total energy before transformation, if you want it, total energy before transformation is equals to total energy after transformation. After transformation. So for example, if I consider any kind of free fall body, a ball is falling freely, free fall. Note it, everybody, just I'm saying you, at a maximum height, it is having only one energy. Anybody can tell what is
Potential
that?
energy.
Only it has potential energy. During the journey, what will happen? During the journey, potential energy
Converts into kinetic energy.
kinetic energy. But before touching the ground, it is having what energy? Only what energy? Before touching the ground.
Kinetic energy.
Kinetic energy. So if you have noticed it here, initially and finally the potential energy, whatever it is there, that is the same energy in final kinetic energy, but in the form of kinetic energy. But initially it is in the form of potential energy, but after transforming into kinetic energy, but still remains what? The energy remains equal. Means if I take the before falling, whatever the potential energy is present, after falling also, the same kinetic energy, which will be equals to what? Everybody, which will be equals to potential energy. That is what it is called as energy transformation. So energy before transformation is equals to energy after transformation. That is what you have to remember. Okay, guys, everybody clear? That is only call it as law of conservation of energy. So law of conservation of energy for a freely falling body, as we have taken free fall. So now we are going to see a freely falling body, how the law of conservation of energy will be there and how we need to do it. We'll discuss it now. So if you take here, all of you, so there is an example, you can notice it in our textbook. All of you take your NCERT book. You can see. So this is an example they have given regarding the activity 10.5. We'll speak about the law of conservation of energy for a freely falling body. So what is that actually? Always, at the beginning itself, we have studied that. So kinetic energy plus potential energy, which is equals to what? Remains constant. That is only we used to call it as a mechanical energy. So sum of the potential energy plus kinetic energy, which is equals to remains constant. If it is remains constant, then what is that, everybody? We will say it is a mechanical energy. So means in the sense of the energy neither be created nor be destroyed, but it can be transformed from potential energy into which energy, guys? At every point, it will be transformed from potential energy to everybody kinetic energy. That is what you have to remember. I hope you all clear, everybody. So anybody having any doubt, you can ask me. So now we are going to prove that how this potential energy and kinetic energy will be transformed, and what is that, either it is true or not, law of conservation of energy, either it is true or not. With the help of this activity, we'll study that. So you can see that activity 10.5, all of you make it. So an object of mass 20 kg is dropped from a height of 4 meters. So you can take it, everybody. So now object is reached to the, maximum height of 4 meters. Now it is maximum height. So it is having only one energy. What is that energy? Anybody? Only it will be having what energy? Yes, please.
Potential energy.
Potential energy. So that is what we have to do it, of course. So it is in rest. So that initial velocity is what? Everyone? Initial velocity is what? 0. Am I right or wrong? So they are asking everything. So potential energy, kinetic energy and all, you can check it. So potential energy is mgh at 4 meters. What is the potential energy? Anybody can tell? At 4 meters. What is the potential energy? All of you. So 4 mgh, correct? Mgh. So mass means what? 20. G value is 10. Height is equals to 4, which is equals to how much the answer? What is the answer? Potential energy. mgh 200 into 4, which is equals to how much? 800 joules. Now, initially body at rest. Body at rest means velocity is 0. So what is the kinetic energy at 4 meters? What is the kinetic energy at 4 meters? All of you.
0.
0. Understanding? So at 4 meters, potential energy is 800. Kinetic energy is 0. So total, if you add it, potential energy plus kinetic energy, 800 plus 0, which is equals to how many joules? All of you. Please respond. 800 joules. Am I right? Yes, guys. Clear?
Yes, sir.
Everybody. Next.
Yes, sir.
Next, at height at 3 meters. 3 meters it is traveling. So all of you observe at 3 meters means, check it, everybody. 3 meters means, so what is happening now? H is equals to 3. So H is equals to 3 means definitely at this point it will be having what energy? Potential energy. So mgh I will calculate. So m is equals to how much? 20, G value is 10, H is equals to 3, which is equals to 200 into 3, which is equals to how many joules, Ra? At 3 meters. At 3 meters, what is how many joules? 600 joules of potential energy. Understanding? Then what about the kinetic energy? 800 minus 600. What is the kinetic energy? Kinetic energy equals to what? 200 joules. So Y means, what is the answer? Whatever the energy loss will be, like the energy lost in the form of potential energy, which is equals to energy gained in the form of kinetic energy. Do you all understand, everybody? Because it will be energy transformation. Yes or no? All of you. Please respond, Ra. So whatever the energy, write a statement. The energy lost in the form of potential energy will be equals to the energy gained in the form of kinetic energy. I hope you all understand. So now at the 3 meters height, it is having a 600 joules of potential energy means, then how much energy converting into kinetic energy? How much energy it is converted to kinetic? Everybody.
200.
200 joules. So now, if you have been written, so write the statement, everybody. The amount of energy lost, the amount of potential energy lost, that is right. The amount of potential energy lost, which is equals to the amount of potential energy lost, which is equals to amount of potential energy gain. Amount of potential energy gain. Amount of potential energy gain. Do you understand, everybody? All of you? So then the potential energy lost here 200. So 200 plus 600, again how much is the answer? 800 joules. Next.
800.
Third, 2 meters height. So we are at 2 meters height. So what will happen, all of you? So 2 meters means again at that point potential energy will be there. So which is equals to mgh. So which is equals to 20 into 10 into height is 2, which is equals to 200 into 2, 400 joules. So remaining 400 joules, where it will be converted, everybody? Remaining 400, it will be converted into what? All of you. So at 400, remaining 400, it will be converting into what? it will be converting into kinetic energy. So which is equals to remains 800 joules. Then 1 meter above, it will be coming 200. And here, how much it will come? 600. Remains is equals to 800 joules. So like that, just above the ground, just before reaching the ground, you can notice it, where H is equals to 0. So potential energy becomes 0. But by the time, complete energy will be transformed to which energy? Everybody, kinetic
energy.
Kinetic.
equals to again 800 joules. So if you notice it, everywhere, the energy neither be created nor be destroyed, but remains the energy conserved. So always sum of the potential energy plus kinetic energy in the case of free fall remains constant. That is what is we wanted. So that is only call it as law of conservation of energy. So tomorrow, sir, how it is true? Sir, simply you are saying energy loss in the form of potential is equals to gain in kinetic. Then tomorrow we will